Good morning. Thank you all for coming. Today's session is Taming the AI Sprawl. And we picked that title a bit intentionally. We've moved past agents that are simply reactive chatbots, and agents are becoming a lot more than that. They're autonomous, decision-making, collaborative, multi-agent systems. And when you have such a system, you really have a problem of an unmanaged AI crisis, where an agent could have executed your instructions perfectly and still have violated your organization's policies. In today's session, we are going to deconstruct the architecture of a modern agent, understand how the protocols of A2A and MCP play into this, and then from there, understand how we can shift down agent governance from developers into the platform. In this session, we are also going to understand the role of observability and what role that plays into agents. My name is Nandan Sridhar. I'm a PM in Google Cloud. I'm joined today by Ameya, a staff engineer at PayPal, and Srinivas Krishnan, a principal engineer at Google Cloud. And together we'll tell you the role of governance and how it plays in governing your AI systems. Okay, so before we understand where agent architectures are headed, let's understand where we are today, where enterprises that we speak to are today in their AI journey. Most of the enterprises that we talk to are sort of in two phases, where they've just started getting with agents in production. They have a few agents in productions. A lot of them are dabbling or experimenting with agents, but those agents are still fairly simple in what they are doing. There's a huge blossoming of agents that are improving the personal productivity of individuals. So these are agents that will help you do your, whatever, craft your email, summarize a document, all those things. But we are still rarely seeing agents that are improving the ROI of enterprises. I suspect that's going to change this year. And that's going to be the start of the agentic era. The second is that AI is now embedded into every application that you use today. Whether it's your expense system, a CRM system, there's AI in every system that you're using today. And that's really a challenge to traditional IT systems because they're not, those IT organizations are not used to this big change. And the third is where your leadership wants to take agents to, which is agents that have agency, to have agents execute processes. You no longer want to have an agent where you ask it how to do something, but you want the agent to simply go do that. And that brings us to this very important point of where governance hasn't caught up to all these expectations that you have from agents. Okay. Now, a lot of what we are seeing in the adoption of agents reminds us of how product-led growth fueled cloud adoption. That's really what we are also seeing with agents. Since governance hasn't caught up to it, you have a lot of teams that are adopting this, not necessarily with IT organizations in sync or with governance systems in sync, but they're adopting it. And that produces a very interesting risk. Unlike your traditional systems, which you could test, evaluate, because there's a finite UI or an API of what the system could or could not do, here you have an infinite permutation risk of prompts. I'm reminded of so many interesting incidents over the past year where, last year you could trick models into saying your life was in danger, and then it would break all kinds of rules for you. It's a whack-a-mole. Something new will come, a researcher is going to find a flaw, and you're forever trying to close that gap. And then there is this very interesting thing of the misalignment trap, where an agent executes exactly what you did, and yet you have violated policies. Consider a couple of examples. You asked an agent to delete a bunch of files, but those files are necessary for you to have been kept for compliance reasons. Or you chatted with an agent to help you solve a customer case. It stored customer information in context or in memory, and that has violated some policy of where you're storing customer info. How do you deal with this? So before you understand how you govern an agent, it's important to understand what goes into building a modern agent. The very first one, this is super obvious to everybody here, but to set the to set the table stakes, an agent has a large language model for reasoning, also has an external context that you give it. That much we all can agree on. But what has changed in the last 5, 6 months is the concept of agent skills that have come. First announced by Anthropic in October, and then published as an open standard in December, we're seeing that agents are adopting skills. So what are skills? Well, to dumb it down, really, it's a markdown file, but it's a set of instructions that tell an agent what to do. It's a complex set of steps that you describe to an agent by providing examples. And what makes a skill very interesting is that they're portable. They're independent of any framework, they're independent of models, they're independent of which cloud you deployed, and that portability and the description of these complex steps, which, by the way, are not predictable, right? And an analogy I give for skills is instructions to bake a cake. Many types of cakes that you can bake. These are multi-step processes. So you're going to describe that in a skill to teach your agent how to bake that cake. What makes it interesting also introduces some very interesting vulnerabilities, because the markdown files contain examples, they could contain scripts, they contain code that an agent can generate. And this is where they can also be exploited. So this is the heart of what goes into an agent: the model, the context, and skills. Now we talk about how the agent interacts with everything outside it. The first is MCP. While the skill is a complex set of steps that it does, each of those steps may require predictability. And that's where MCP comes in. Let's take an example back to our baking a cake. You want to set the temperature of the oven. That's a predictable step. That's deterministic. You want that to be exposed over a tool, because when the temperature is set, it's not left for chance. And MCP does that. It gives you those transactions and tools that your agent can communicate with outside. And now your agent is not going to be the only expert or an expert at everything. Your agent will want to communicate with other agents. Again, back to our example, you may have an agent that's an expert in icing. So an agent needs to communicate with other agents, and the standard to do that is A2A. In A2A, agents communicate what they're capable of through an agent card or a discovery card that tells an agent whether it should invoke this agent or some other agent. And this gives us an app store type of a moment, because now you have an app store of agents where each agent describes what it is good at. That way, an agent can communicate with the best possible agent for a given prompt. And this was what makes it truly powerful, because you don't have to pre-decide what an agent has to communicate with. It communicates with the store, finds the best agent for the job, and then interacts with it. While we have this as the architecture of an agent, it also brings forth some interesting ways in which agents can be exploited. Attackers can use prompt injection, a very common mechanism for attacking agents, right? You can have PDFs that contain hidden information in it when submitted to an agent, and now you trick an agent into treating that as instructions. You could have images that have information in it that are not clearly visible to humans, but agents will make sense of it and can execute on it. And you're constantly creating guardrails that look for keywords or whatever and trying to block it. And then you have one of the benefits of A2A and MCP also becoming a vulnerability through rug pull. Now, the MCP and the A2A standards have a discovery mechanism. It's completely dynamic. Agent can discover tools and say, well, what do you have capable? Same thing with agents through the discovery card. And when you have such a system, the very first connection could give you a valid list of tools or a valid list of skills. And then comes the rug pull. Your second or third connection can be changed to have malicious tools or malicious skills. Now, you trusted the agent or the MCP server the first time, but your subsequent calls continue to use these malicious things, all the while assuming that your very first connection was trusted, and therefore subsequent conversations were also trusted. And that's a type of attack. And the last one is tricking an agent to fetch or to exfiltrate data into other resources. These are the types of exploits that are there, and as researchers dig into this, more types of vulnerabilities come into agents. So this is where we are. This is the problem that we're dealing with. Okay? Now that we have seen this, let's make the theory real by me handing it off to Ameya, who's going to talk about some of these challenges that he's facing at PayPal. We'll make it real, and then I'll hand it off to Sri.
All right. Thanks, Nandan. So I'll be talking about some of the challenges that you usually face while building out these multi-agent systems. We are moving towards an era where we have agentic solutions that are moving into every system. So what is the actual need to develop these agents? In terms of investigative workflows, you have analysts looking at disparate systems, multiple data sources, which are fragmented and siloed. You have workflows that they need to step in and perform multiple steps within a particular life cycle, and that requires additional volume, and also in terms of operational capacity, it can scale up to that. Besides that, you also have the human judgment, where analysts looking at different set of data might have some variability in it, and depending on the user, you might have various different outcomes. So what kind of helps here is the agent capabilities. So how do agents help us in solving these operational bottlenecks? You have context aggregation, where agents are able to unify the entire data structures and all the data stores, and it's able to give a unified view. It's able to perform, look into these data sources, and also able to identify and flag risk signals that might not have been visible to human analysts. And also it helps deliver certain automation where it's able to perform certain actions independently without having a lot of human intervention. We all know building out agents and multi-agent systems requires a lot of building blocks. You might be aware of the common ones like building out MCP tools, having some sort of RAG pipelines to ground your data, but you also need some other things like having a unified registry and identity. So all of your agents that you're building need to live in a centralized registry for it to be discoverable, and you also need to have a unique identity so that when agents are communicating with each other, they have a central identity that they can refer to. In terms of orchestration, you need a single orchestration to bind all of these agents together to perform multi-step executions and to ensure it's done reliably. Also, you need some sort of a human oversight where you have human in the loop that is reviewing all the output that the agent is performing, and then you have to manually approve that. Besides that, there's also a challenge of modality and languages. So you might have multi-agent systems that are operating on different type of inputs, like you might have PDF documents, you might have images, you might have other sort of media files. So this kind of also needs to factor in when you're designing these systems. All of these building blocks kind of go together to form a complete end-to-end solution. But then it also leads up to some sort of engineering complexities when you're trying to develop this. So think of all of these agents working together. You need to make sure they're operating reliably, they are seamless with their interactions with each other. And also in terms of the context management, when you have multiple agents that are trying to perform a single unified task, it needs to have a consistent unified context of what the problem that they're trying to solve. Also, in terms of the workflow coordination, when you have multiple agents that are trying to perform all of these different steps, it needs to be coherent in such a way so that all of these steps are synchronous and kind of coordinate seamlessly. So all of this kind of also leads to AI sprawl, where the democratization of AI across all of these different industries is causing developers across all different teams to try dabble out with a different type of agents, building out their own configurations. So this kind of leads to duplicate efforts among different teams. It might have the same sort of capabilities that are overlapping across different agents. So you need some sort of visibility into this to understand, like, as these agents scale up and then the count goes up, how do you kind of track all of these agents and then like have some visibility into like what tools are they invoking. Also, like as this expands into the enterprise, there's governance gaps where you might not have visibility into what these agents are doing, and it can increase risk like cost and security. So speaking of cost, like what are some of the factors that attribute to contributing to the cost of the multi-agent system? So the model that you choose can also directly impact what sort of cost that you incur. So if you're using like a premium model for your particular use case, that might lead to a higher cost because the price per token is larger for the inputs and output. Also, depending on like the multimodal processing where you're using images or PDFs, that might be higher than your traditional text-based workloads. Also, having like multi-step orchestration, that kind of leads to agents calling other agents, having multiple invocations of tools. So this kind of leads to a higher token cost and also increases your latency as well as the cost. So looking at some of the security and abuse risk, like what developers need to prevent from is, one is a typical prompt injection where you're having agents that are taking in malicious input or like some instructions that are not meant to be executed. Besides that, you also have the risk of data exposure where you're providing sensitive information, you're hosting sensitive information that needs to be governed within this residency rules, and also like agents trying to invoke tools that are probably not meant for that use. So this leads to like development, like deployment options and controls that we need to bake into the system itself, where you might have to choose how you want to deploy the solution, whether it's like a cloud-based solution or you're deploying locally to have in more flexibility. Also, depending on your use case, whether it's like a customer-facing solution where you have external users trying to interact with it, or is it something like meant for internal tooling. All of this policy enforcement needs to happen through like guardrails and approved workflows, and we should have operational visibility into like what tool calls are happening and like how the agent is behaving. So this leads to the governance challenges that we typically face. So you have access control where agents have a specific set of actions that need to be available for that particular agent. And in terms of data provenance, where the data that the agent is relying on needs to have the right metadata so that it can attribute it back. Also, in terms of explainability and auditability, your agentic systems should be able to tell you like in terms of what sort of decisions that they've taken and like what have the outputs been in terms of the outcome. And also like all the actions that have been performed, including the intermediate steps, those should be relevant in terms of how they've come up to that particular agreement. Moving on to the next set of challenges, we have the problem of evaluation where you're trying to evaluate like whether an agent has generated output that is up to that standard, and also in terms of the decision consistency. So in terms of like regulated industries where you might need an output to be in a certain specific ways, LLMs and multi-agent systems might not be able to adhere to that same format each and every time due to the non-deterministic approach. And also you have to have some sort of runtime controls where you have safeguards such as rate limits, cost controls to make sure like you're not spiraling out of your budget. And last but not the least, like you need to have some sort of a kill switch so that you can disable some agents or some tools in terms of if it's taking if it's going like having some unsafe behavior or like system errors. So yeah, that's all from me. I'll hand it over to Srinivas.
So what I'm going to do is try to go back and start unpeeling some of the layers about how we have kind of built the agent governance pieces to kind of solve the problems that we talked about, right? So one of the core principles that we have is that we treat, you cannot treat agents like APIs. That's what traditionally has been done. their behavior is more probabilistic, right? Their reasoning paths are non-deterministic oftentimes. So what we're really trying to do is we're trying to take a shift-down approach, which pretty much means that we want to take the burden of securing these agents, managing them at scale, and pushing it down into the platform. So this is a disclaimer. There are some statements we're going to make which are forward-looking. I'm required to put this on, but let's keep moving. All right. So Nandan talked about, for example, a single agent and how do you go from a single agent and what the evolution is looking like. So if you think about building a single agent, we already talked about that. It is very simple. A lot of you already have experience doing that. But deploying 100 inside an enterprise gets exponentially harder, right? So within a single agent, you can think of the endpoints are kind of predictable. You can trace one. You can look at the traces. You can look at logs. You can look at linearity. Once you get into like chain delegation, when you start getting into like reasoning loops, you look at token churn, which is actually going across these agents, it becomes that much harder. So one of the things that we have noticed as we talk to customers, like Ameya and other folks as well, is like single agents oftentimes, you can predict them. But when you start doing n greater than 10 even, if I say n equal 100, but even tens of them, it introduces a lot of things like compounding costs. It introduces infinite reasoning loops which are bouncing across these agents. And then you also have this thing of even if they're not connected with each other, there's this massive shadow AI, right? Essentially, because of the whole PLG motions of it, a lot of folks, a lot of agents are getting onboarded into the enterprise. So standardized perimeter security that you all have thought about traditionally kind of breaks down here. So one of the things that we also want to do is we don't want to reintroduce everything from scratch, because that's a really hard context switch in terms of what a lot of pieces have been built. So we don't want to invent IT governance. We want to extend them and add new things as needed. So you can think of a few things. For example, what's a replicated binary? A replicated binary can we think of an agent. It's running in different points. The network endpoints that exposes. It's the MCP tool, the A2A cards, the A2A endpoints. A static IAM role that you're familiar with, service accounts, we want to secure them more at their ephemeral agent identities, and we'll talk about that. So what the agent platform is really trying to do is helping you secure AI systems. So it wants to kind of take the same operational muscle memory that you built over the years and then give you those offerings in those same verbs that you kind of used to. So this is the slide we're going to start breaking things down with. One of the things what we want to do is we want to kind of, if you think of the AI sprawl, we don't want to build it in silos. We really want this unified center of gravity, right? So if you think of your enterprise right now, we can think of it as deeply fragmented, right? You have custom agents running in different places. Some custom agents are running on-prem. There are third-party skills which are embedded in different SaaS tools. There's, for example, Slack. Then there are managed models running Google Cloud. They're all running in different places. They're all disconnected. They're all oftentimes speaking different languages. They're kind of bypassing your IT systems. The shift that we're trying to push through and what we introduced over the Gemini Enterprise platform is that the agent platform is essentially operating as a universal bridge. We are breaking down the compute runtimes. So we really don't care if the agent runs on Kubernetes GKE, it runs on Cloud Run, or if it's running on legacy, right? As long as it is onboarded into the central of the ecosystem, using open protocols like MCP and A2A, we're able to bring it together, all these disparate pieces into the governed ecosystem. And we'll talk about how that occurs. So the thing that we're really trying to get together is like, it doesn't matter if your agent was built or what model it uses, as long as it brings in, it's governed through the registry, it is governed through the gateway pieces that we'll talk about, it becomes secure, discoverable, and fully managed, and provides all the properties that we're going to talk about. So how do we build this unified core? So we think of it as 5 foundational pillars, and I'll unpack each of them, right? So the first pillar that we talk about is the agent registry. The agent registry, you can think of it as your central catalog. It has centralized naming. It has specific naming protocols that we are built. It allows for discovery. It's a catalog. And we also talk about how singular agents can interact with it. Then we have the gateway, which is a really powerful thing, which essentially is your routing layer. It controls your ingress and egress, what your gateway, what your agents can do and access. And then you have agent identity. This is your trust, right? So agent identity is your cryptographic trust, your workload identities that associate with an agent. We'll talk about how we think of agentic identity slightly differently, but we're also borrowing existing pieces and moving them forward. And then we have policies, right? So we want policies to be pluggable. So your rules that already exist, how do they plug into the AI system? How do we do centralized enforcement with things like model armor? How do you bring in different, even 3P guardrails into it? How do you do ODZ policy as part of it? And last pillar is observability. A good system only operates if you can observe what it's doing. You want to know its side effects. You want to look at cost. You want to look at the end-to-end real-time tracing and how the entire platform kind of enables that. So first pillar we're going to talk about is the agent registry. So the agent registry really is your centralized catalog, right? It's a definitive catalog across your entire organization of all the agent tools and MCP servers that you see, right? It brings in, it is your single source of truth. So this is the catalog that has both the shadow UI and the governed side of it. It is every tool that's been deployed and every agent that's been deployed across the entire org. One of the key pieces of this is also how we think of agent naming. Each agent that is in this, or each MCP server, which is inside this catalog, has an immutable identifier. And that identifier also has specific properties, which essentially means that for it to be governed, it needs to be authenticated and published into the registry for it to be available for other agents and tools to consume. So one of the things that we also want to do is that we want to kind of make it easy for these things to come inside the agent registry. So implicitly, when you run on GCP, it does, if you're on Vertex AI, Agent Engine, if you're Gemini Enterprise, or other agentic platforms, for example, you're automatically registered into the catalog with zero developer friction. That automatically happens. You can enable the APIs, and we're bringing all the data across the GCP ecosystem to bring it. It also integrates with the existing CI/CD pipelines, right? So, and your processes. So if you're running on GKE or Cloud Run, you can easily onboard your agents and MCP servers with a few annotations to bring it in. So this implicit registration is all meant to kind of remove developer friction as much as possible. Developers can then also use things like skill-based lookups. So instead of using service names, they can also query the registry for a data analysis skill. So we support things like semantic searches. We support things like keyword searches on top of that. The agents can directly also interact with the registries to look up these tools and the other agents that they need to. Lastly, there's also things like Apogee, where their existing enterprise APIs, when they get converted, they also show up in the registries as MCP tools. And this happens automatically without the developers having to do anything extra. The other piece that I want to kind of talk about is like we have this catalog, which is this essentially this buffet where you can go and take any agent that you want to. But we also kind of have this view of an per agent lens. So you can think of the catalog as every agent available out there. So you can have a financial agent, you could have a developer agent, you can have 10 different types of agents. But when you want to build one, we also have this view of an agent lens where it is a scope reality. So an individual agent can only see highly curated authorized lists and also authorized agents that it wants to interact with. And we'll talk about how this actually happens in the next thing, but this is one of the more key features of the registry and scoping it down to on a per agent basis, which we also will talk about as agentic applications. So the second pillar we're going to talk about, the registry itself is a catalog. You can curate it to the agents, but how do we actually do runtime enforcement? So it happens through the gateway. It has two basic portions of it. It has network enforcement, and it understands protocols like A2A and MCP by default. So one of the pieces here is you can think of the gateway as the overall air traffic controller. Every traffic that can ingress and egress into an agent, it sees all of it, intercepts all that traffic, the client to agent, the agent to tool. So this is an Envoy-based data plane that intercepts all ingress and egress traffic from the agent, so it's able to enforce policies on top of it. It is integrated directly into the registry, and it's default deny. So if, for example, if the registry is empty and you deploy an agent for that specific purpose and you put it, and the gateway is enabled on top of it, it will only operate on authorized tools and authorized calls that the registry allows it to do. So all the access control policies and pieces you can set up at the registry, and all the different gateways across your org will pick it up. It's also pluggable. So we'll talk about how policies can be pluggable using service extensions. And it natively understands agentic protocols. So it can parse JSON RPC, it understands MCP, and pretty soon A2A, and exactly understands what the agent is supposed to do. And on top of that, we have layered different pieces, for example, observability and agentic security to build on top of it. So the next pillar is agentic identity. So we think of agents having dual authority, right? So there's a human identity portion of it. So they have their own authority. So for example, the agent's accessing things like BigQuery, is the agent allowed to access or not? That's one part of it. And then you have user delegated authority. For example, you want to read Slack on your behalf. So we're treating them differently, and we kind of talk about them as human identities and non-human identities. And we also introduce this concept called agent identity, right? So every agent has its own specific identity, which is built on SPIFFE. So we're kind of extending SPIFFE workload identity to support agentic identities. These identities are also ephemeral, and they're tied to the agent lifecycle. So that means that if the agent goes away, the identity that's associated with it also disappears with it. We also do things like proactive certain rotation every few hours to kind of expose that. As part of that, there's also this auth manager and binding portion of it, because agent code can be susceptible to injections. We don't let it handle raw user credentials. So the auth manager, auth bindings essentially act as the secure vault where you can add the tokens, the user-bound tokens as part of it, and the gateway we talked about before handles the decryption, injecting the tokens at the network edge. The next piece of this is kind of putting it together to do pluggable policies, right? So there are different kinds of policies. You can think of as, for example, someone might do a cost budget policy. I think Ameya talked about that as well. But you can kind of enforce things like Unify tokens and cost budgets. And then they have security policies. For example, you might want to have very specific rules on what you want to enforce, what kind of orchestration you want to do, what kind of context you want allowed. There's also things like trust and abuse classifiers, which you get through Model Armor. And then overall postures, right? For example, you might want to have a specific DSPM policy that associates with it. And you can do all of these things through the gateway and the extensions that we're going to build on top of it, and associate those individually to the agents that we provide through the registry as well. So as part of this, one of the things is that we think of them as two layers, right? So there is the IAM access control, which is layer one, right? This is standard Google IAM. If a client or agent, for example, is not in the agent registry, the gateway will automatically block it. Then you have SPIFFE identities, which understood across the board. And this is existing security policies that you have. Because every agent also has a mechanical identity, we also map them to the Google IAM roles. So if they're unregistered in the registry, they're unauthorized to access, and they automatically get dropped. So this is all powered through the agent identity, and it has strict perimeter enforcement through the gateway. But then static rules, one of the things that we rule out, are not easy to understand, and they don't actually handle agent interactions very well. So we want things like semantic governance as part of that. So one of the things that we want to say is like allow people to specify this using plain English. You can write things like do not share a customer's PII with third-party tools, and then those specific natural language gets converted into policies the gateways can go enforce. So the gateway is able to intercept the context and then do things specifically based on what the prompt that was provided to it. The last pillar is agent observability, right? So one of the things is we want agents and the whole platform not to be a black box. You cannot scale a system, and you can't if you don't know why it made a specific decision. So it is a very key part of that. There are three kind of pieces that we're introducing as part of that. There's a graph. There's a unified graph that we understand the end-to-end ecosystem pretty well. It automatically infers and maps agent-to-agent interactions, agent-to-tool interactions. It uses the OpenTelemetry standards. So it uses the Gen AI semantics to kind of label and tag traces and logs that are emitted from it. And then you have things like logs and correlated reasoning, so you can actually understand all the end-to-end LLM prompts that occur as part of that. All of this is also engaged as part of attribution. So you can actually attribute where the calls came from, which specific agent came from. As you remember before, we introduced specific identities and specific names as part of that. And those names kind of flow directly into the logs and traces so they can easily able to attribute where those calls are coming from. So this is a very powerful piece to the agent platform that kind of allows you to also look at all these different pieces of your system from different pieces from like traces to logs to metrics with the agent names and identities that go part of it. So that's kind of 5 pillars, right? One of the other things that we kind of want to also talk about is we all live in the real world, right? So your AI agent have to live next to legacy databases, legacy systems. So there's a concept that we're going to talk about in the slide next, which is the agentic application, which kind of takes your existing enterprise interfaces and kind of puts them and kind of packages it so that you can do things and expose those A2A endpoints or MCP endpoints as well. So in the end, before I hand it over to Nandan to talk more about the future-looking pieces of this, one of the pieces that we're introducing pretty soon is this thing of an AI application, right? This is it's kind of the ribbon which kind of is meant to tie all the pieces together. It has things like how do we think of multi-agent orchestration? And this is where you build an agentic application. So we don't want people to think of managing an individual agent. We don't want people to think of managing individual tools. You kind of put them together into agentic application. Each agentic application comes with its own ingress and egress gateways. So it kind of exposes a specific registry, which we talked about before, the lens. And you can do things like you can do top-down governance as part of that. You don't need to go and provide security policies to hundreds of different nodes. You can do things at the semantic layer, and it automatically goes across all of these different agentic applications that you're building. You don't need to worry about sub-agents as well, because the governance that you provide as part of these agentic applications is fully inherited across all the agents that are part of this perimeter. You can attribute all costs for this agentic application. For example, you might have a CRM application which interacts with 10 different sub-agents, 5 different tools, and you can kind of note them together and say, this is what the cost of running this agentic application provides you. So the ultimate goal for us essentially is we're giving ability for people and teams to have control over the business logic, right? So that's what the agent application is supposed to be. It is supposed to kind of take your business logic and put them into a grouping of different agents and tools that work together to provide that. So the next thing we're going to talk about with Nandan is how we kind of put them together in the Gemini enterprise landscape.
Thank you, Sri. So what we saw thus far is very producer-centric view, right? Somebody who is administering agents, governing agents, and so on. But at the end of the day, that's one side of the story. There's also the other side. Once you have all those agents, how are they used? I mean, it's only useful if they're also used by consumers. So there are 2 aspects I want to bring. One is agents in your agent registry serve as the distribution layer for Gemini Enterprise. So with today's launch, what we're doing is integrating Gemini Enterprise, where Gemini Enterprise will find agents in agent registry that you can then expose to the users of Gemini Enterprise. So agent registry will have the universe of what agents, that's a curated list. You can find them from marketplace, third party, agents that you build, high code, no code. All these agents are now there, and now you can choose to distribute them to Gemini, through Gemini Enterprise to your users. But you have another segment of users. These are your developers. The agent registry itself is available as an MCP server. So now you can connect your favorite IDE, or you have a skill for it, and now developers can start to find agents and MCP servers that's curated and allowed for them to use from the registry right into their IDE. Additionally, we've got skills to tell how to create code for ADK. So if you're using ADK, then it'll also help you how to write the code, leveraging the registry into your IDE. So these are sort of ways in which you can start to consume agents that are in the registry. Okay, what we'll do now is a quick walkthrough of the things that we talked about. So we'll have a demo, and I request now that we switch to my laptop. All right. I hope guys at the back can sort of see this screen. If you guys need me to make it any bigger, let me know. Okay, so what you're looking at is the agent registry. This is the first pillar that Sri talked about. Okay? This is where I've aggregated all my agents. And I'll quickly bring to your attention a few of the things that you see here. So the first thing is we support both A2A and non-A2A agents. As much as we'd like to see every agent implement A2A, because that's a good thing, then agents can discover and collaborate with each other, the reality is not a lot of frameworks or not a lot of users have created agents that are A2A, but the registry has both. Second, you'll see that there are agents from all platforms. So I have my GKE agents, my Cloud Run agents, my Gemini Enterprise agents, Agent Engine agents. All my agents are included in the registry, as well as third-party agents. Now, if you are going to onboard a third-party agent, then that is done either through the UI here, but you also can have Terraform, G-Cloud, or your favorite CI/CD process to onboard that into the registry. Now, if you clicked on one of the agents, you'll start to see important information about that agent. You'll start to see the skills that it possesses. Now, this is not agent skills. This is A2A skills. Unfortunate naming there, but this is the agent's A2A skills that the agent has, as well as the identity associated with this. And this is that second pillar that Sri talked about, how agents have an identity. It's not just agents. We also have MCP servers in the registry. But before I move to MCP servers, let's continue with agents and talk with agents and the identity, and continue with the two aspects that Sri brought up. One is the agent itself has an identity, and the second is delegated identity. This is where you want your human to also log in. And what you're seeing here is the ability to associate your agent with an identity for delegation. So I'll give you the example that I have here. I want my agent to access Google Maps, but I want Google Maps to use an API key, which is separate from the agent's identity. To do this, I create an auth provider which supports three forms of authorization: two-legged OAuth, that's your client credential grant, auth code grant, or three-legged OAuth, and in this case, an API key. So I configured this, and therefore, associated with this agent, in the case of OAuth, are the client ID and secret. And once I have that, I can then bind that client ID and secret to an MCP server, which I have for my Google Maps. Now, by creating this binding, if you're using Agent Development Kit or ADK, that agent already knows which client ID and secret to use when connecting to an MCP server. This is no longer a responsibility a developer has to know about. Think about it. Your agent is going to connect to many MCP servers. Very likely, those MCP servers and agents use different client IDs and secrets for OAuth. All that information is now externalized into the registry through bindings. As a developer, all I need to do say is, I'm going to use this MCP or that agent, and then the auth is done for you. Moving along, we have MCP servers now. The registry also serves as your source of truth for MCPs, and these are all the MCPs available. So what you're looking at are MCPs created by Google, but you can also have third-party MCPs, so your GitHub MCP server, or MCP servers that you may build using FastMCP on Cloud Run or GKE. All of them get centralized here. Now, not all of them are represented as MCPs or agents. Often, you do want your agent to access APIs. A classic example is that your agent needs to access Okta's API to do some OAuth, right? That's an API, that's not an MCP, that's not an agent, that's none of it. But you still want that governed. You still don't want to allow anyone access to it. You still want to say which agent and which parts of Okta needs to be accessed. So you can store those endpoints in the registry for the purposes of governing through the agent gateway what endpoints your agent can access. And those endpoints are also stored in the registry. Now we'll move to the third pillar that Sri talked about, which is the traffic control or the agent gateway. So the agent gateway, as we saw in that diagram, it's a sandwich, right? It's a sandwich that protects the ingress and egress. Okay, I'm running out of time, so I'm going to quickly switch to the other two pillars. So the agent gateway protects the traffic coming in and out. And then you have policies, the IAM-based policies for your agents. And then I'm going to switch to some of the topics that will deep dive into the topics we talked about. For agents, gateway, and policies, there are 3 separate sessions on this. I thank you all so much for your time and for coming here today.